Hello everybody. Once again I am here with you for our next session related with our solid state physics paper number 13A. Again myself Dr. S. D. Chavan, Department of Physics, Adarsh College, Hingoli. In previous session we have seen two-dimensional and the three-dimensional Bravais lattice. In previous session also we have discussed a little bit about the what type of the symmetry operations are to be there, how the crystals are going to be formed. Now here are the some simple crystal structures we are going to discussing today's in our today's lecture. Now what exactly these simple crystal structures are there little bit in detail when we are moving in this case. So as far as the simple crystal structures are there are basically divided in two parts. One is to be closed packed structure and another is to be loose packed structures are to be there. Now closed packed structures, that means to be the unit cell, one unit cell contains at least 12 atoms or greater than the 12 atoms are to be there, then we can say the such type of the crystal structure when it is going to be formed, that is nothing but to be comes under the closed packed structure. And whenever the less than these 12 atoms are in the one unit cell, then we can say the such type of the crystal structure or the lattice is going to become under the loose packed structures are to be there. Now basically these are the comes close packed structures are to be comes with the monoatomic crystals are to be the best example related with the structures are to be there. And the coordination number definitely in this case are to be the 12, because each atom is going to be surrounded by the 12 atoms are to be there. And in this case it is somehow closed packed structure is to be there, divided in also in the two parts, or the basically having the two basic simple examples for this closed packed structures are to be there. Number one is to be hexagonal closed packed structure, and the second one is to be the face center cubic structure is to be there. In short, for this hexagonal closed packed structure, this is in short also called to be as an HCP, that is close hexagonal close packed structure is to be there. And of course for the face center cubic, that is the FCC is to be the structure name it is given in short. So what exactly this close packed structure, and what exactly to be here for the your hexagonal closed packed structure is looks like, or what exactly it contains, that we will see in detail now. Now, as far as the hexagonal closed packed structures are there, we already seen that whenever the atoms are to be greater than 12 or 12 atoms are there in one unit cell, then it is called to be as an Rashi, or the closed packed structure is to be there. So here are the basically the layers of the atoms if you see in the solids that are somehow distributed in this case. Now in the hexagonal closed packed structure, or basically in the closed packed structure, what happens as far as the layers are going to be concerned. Now suppose this is somehow the example for the case where I will show you here, the one point or the one atom is surrounded by the six atoms are to be there, and this is called to be as in first layer is to be there. Here it is shown with this case. If you look at in this diagram in simple way, here the first layer which is to be shown here with this case, this one is to be a first layer, A is to be there, and such type of the layer is called to be A layer, where there is even center atom, and this atom is surrounded by this supposed to be as in six atoms are to be there. Now look at this center one, and this is to be six, 1 2 3 4 5 6 atoms are to be there. Now this is your first layer, it is looks like to be this one. Now this first layer is having some grooves, that is gaps are to be there. These grooves are, this is how somehow the A layers grooves are to be there. These are filled with the another B layer, and this B layer contains basically three atoms are to be there. Now where are the grooves, that grooves remaining grooves where are to be there, This is somehow placed on your these grooves. These three atoms will be on the such type of the grooves. It will be placed. This is what A layer, and this is what the B layer is to be there. A layer, B layer. A layer contains the six atoms surrounded by it, and B layer is to be having the three atoms are to be there. Again, the third layer will be coming. Here it is to be shown with this case. Here it is to be the B layer is to be there. If you look at this case. Now a third layer will comes in this such fashion that whatever the grooves are remaining in the A layer, that will be covered by the next layer, and that is again containing the such type of the again six atoms surrounded by the towards the one atom is to be there. And when I am putting in this fashion, it will looks like this. So how the structure is going to be formed for the your hexagonal case. And here if you look at the systematically, here is the first A layer is to be there. This A layer is this. Whatever the grooves are there, I will repeat this case. These are the first layer A. Center atom A is to be there, and here are the six atoms surrounded by it. This is your A layer. Here are the grooves, empty spaces are to be there. These are filled with this another B layer which contains the three atoms. On these grooves, these atoms are going to be placed in this fashion anyway. So as I am covering this way, the few grooves are remaining. Now empty where the values are empty, that are again covered by the third layer, which is similar to A layer, equal to A layer. That means it is also containing six atoms surrounded towards the one atom. So it will cover remaining grooves of the A layer, and somehow it gives you the structure like A B A B. Again the next will come with the 3. Again the next B will be with the 3. Whatever the grooves are there, it will cover in this fashion with these three atoms are to be there. So in this way this structure is going to be developed as such as a way, and the lattice is going to be, or the whatever the solid is going to be formed in this fashion. So whenever the such in the hexagonal crystal structure is to be there, such type of the AB layer structure is going to be formed. And in this case, how what exactly the grooves are here in the A layer, whatever the grooves are remaining, that is covered by this B layer, and the B layer is to be somehow whatever the grooves or the values remaining by the your whatever A in the A valley, that are going to be covered by the next layer. In this fashion, this structure is going to be developed in the hexagonal closure packed structure. So if you look at in this case, here are the A layer, this is what B layer covers, and whatever the grooves are remaining by this particularly A layer, that is also covered. That means to be here and here, whatever the grooves are remaining, it will gives us to be as a third layer is going to be formed, that is C is to be there. So this is what the structure exactly for the closed pack hexagonal closure packer structure is to be there. If you look at this small unit cell in this fashion or in this case, then you will see exactly how this is going to be there. Look at this case where these three unit cell unit are to be here. This is what I have shown you. The center atom is to be here. Here it is to be there. I will repeat this case. This is what the center atom here at this stage, and whatever be these six atoms are 1 2 3 4 5 6 atoms are to be there. Likewise this is to be, this is your layer 1, and if you look at this here, it is shown with the A layer is to be there. And what exactly the B layer? B layer, it contains to be three atoms which covers in this fashion. Likewise this. So here is the B layer. This is what, if you look at these 3 points are to be there here, or the atoms are to be there here is to be the case. Three atoms are there. Again, if you look at the third layer, which is similar to this A layer, that means again it is written to be as an A because it is similar to first one, first layer. So this is how this of either you can call this is first, second and third, likewise similar way is to be there. And again it is to be having the same case where the one atom is surrounded by the six atoms are to be there. So the structure where it is given to be as an AB layer is to be there. If you look at this again, here it is to be the six atoms are to be there, and in this fashion the structure is going on and on and on. This is what the basically in this your hexagonal closed packed structure arrangement is to be there. Now it is type of the packing or the stacking is nothing but to be also called to be as an hexagonal closure packed stacking, or hexagonal closure packed structure is to be there, or HCP is to be there. Now important factor here are the three units are there, that if you look at this one is to be the unit cell, this is another unit cell, and this is another unit cell. So in this fashion these are the three unit cells set is to be there. Now as far as if you look at this again the case where the atoms distance is very less, if you look at they are actually connected to each other. And if you look at this case where the distance atomic distance small a is to be given with the 2r. Now what exactly this 2r case is to be there, no doubt this one atom and this one atom both are having radius, that is this is 1r and this is another 1r. This r and this r gives you 2 r's are to be there, and that's why the atomic distance in between them 2r. That means already they are connected to each other, but the distance how much it is to be there, that is 2r from the center point, center of the atom. The distance is how much it is to be as in 2r is to be the another atom center point of the atom is to be at a distance of 2r, that is called to be as an atomic distance. Either they are connected to each other, but the distances in between them it is to be written in this fashion is to be there. So primitive cell is the part is to be shown here, whatever be the unit cell is going to be formed. In that case also we have seen that how the what is mean by the primitive and cell unit cell and the non-primitive unit cell in detail in the previous session also. So moving in that case we have seen that how the non-integer number gives you non-primitive unit cell, and the integral numbers are giving you the whatever the unit cell is formed with, that case is nothing but to be called to be as an your primitive unit cell are to be there. And for that whatever the conditions that is already we have discussed in detail. Now as far as this structure hexagonal closed packed structure is to be there, 12 atoms located at the corner, you will say the 6 at the first one and the 6 at the top, that is 6 plus 6, 12 atoms are to be there. 2 at the center, the first is to be at this center, and the top one is to be the another one is to be, that's why the 2 atoms are at the center, and the 3 atoms are to be uh, completely inside the layer. These are the 3 layers. If you look at the same case here again, these are the 6 atoms surrounded by the 1 atom. This one is the 1 atom at the center, instead of 2 1 is to be here. These are the 3 that is completely inside, these are the 3, and again one another layer that is to be with the 6 atom with the one center point, and that's why it is to be given you as a 2. And that's how the 12 atoms are in the located at the corners, these 6 and these 6. That is how the 6 and 6 plus 6, 12 atoms are to be there. So if I want to find out the effective number in this case, so 12 atoms distributed is with the 1/6 of the part, every part is to be atom of if I calculate in that case, that is what it gives you. To calculate the effective number, it is nothing but to be giving me 12 into 1 by 6, it is divided in that fashion every surface area. As far as the 2 points, that is center point this and the center point this is going to be concerned, in both are to be covering the half layer, sorry, half surface area of this surface area. This side it is covering half surface area, and the second atom is covering this half surface area, this half surface area and this half surface area, not both the side, and that's why it is 2 into 1 by 2 it is to be written. As far as there are three atoms, which are these are the three atoms completely in this inside the your lattice is to be there, and that's why plus 3 is going to be there. So total effective number for such type of the hexagonal close packed structure is nothing but to be, if you calculate this, it will come to be as an 6 is to be there. So this is how the effective number is going to be calculated, and the effective number for the your HCP is nothing but to be 6 is to be there. Now as far as I already told you interatomic distances, distance of the atoms are to be there. C is nothing but to be given here to be the height of the unit cell, and in that case if I want to find out the distance between the basically two adjacent layers, that means to be I am talking about the distances in between the layers. This is B, A, B. Once again these distances are going to be somehow giving you calculating to this. There is a particularly interatomic distances are playing important role, and the height of the unit cell C, it is given represented in this fashion also. So C by 2 is nothing but to be the distance between the two adjacent layer is to be there. So this is all about for the your height, or the sorry distance between the two adjacent layers are to be there. And for the relationship between the high center sorry height of the your unit cell and the interatomic distances, the relationship if I want to find out in the HCP, excuse me, in that case HCP structure having the relationship in between the unit cell height and your interatomic distances are nothing but to be given with C is equal to 1.63 A. That much amount of the height relationship is to be there. So increased by that much of amount, whatever the interatomic distances are to be there, if you multiply with 1/6 of that interatomic distances, the whatever be the height of that unit layer or layer to layer height is going to be there. This is what the simply represented here in this HCP, what exactly the height and the interatomic distances relationship is to be there. If I moving forward again, if I wants to find out the packing fraction in this case, but first we have to understand what is mean by the packing fraction is to be there. To understand this, it is simply nothing but to be the ratio of the volume occupied by that atoms in the unit cell to the whatever be the total volume of that unit cell is to be there. First of all, how many atoms are going to be there, what is the packing fraction, how packed they are, the unit cell is going to be there, that is nothing but to be giving you packing fraction, and this value will decide what exactly the close packed structures having the packing fraction and what exactly for the loose packed. With that value packing fraction, you can also find out either it is closer packed structure or either it is loosely packed structure is to be there. So it is simply nothing but to be how many atoms are used in that unit cell, their volume, that 12 atoms are using, their volume is going to be there to whatever be the total volume of that unit cell is to be there. That ratio is nothing but to be called your packing fraction, and it is denoted with the small f point is to be there. And packing fraction for the HCP, it is going to be calculated in that fashion, putting all the values relationship between the height units, unit cell height, interatomic distances relationship is nothing but to be, when it is going to be calculated, the packing fraction comes, that is to be 0.74 is to be there. So as far as the hexagonal HCP is to be there, the packing fraction is 0.74 is to be there. As far as the example for the such type of the HCP is nothing but to be the metals like magnesium, zinc, cadmium and titaniums are to be there. These are the crystal structures comes under this HCP structure are to be there. म्हणजे मॅग्नेशियम, झिंक आणि कॅडमियम आणि टिटॅनियम यांच्या जे स्ट्रक्चर्स आहेत हे HCP सारखेच म्हणजे totally it is like HCP is the nothing but to be the examples are to be there. So this is what your hexagonal closure packed structures are to be there. The whatever be the actual appearance is to be there, that is also I have shown with this models are to be there. So related, this is what the first closure packed structure is to be there in the same fashion, but with the some little bit differences, with the some few differences. The another one, that is your face center cubic, that is FCC structure is going to be formed. So this is also under the your closer packed structure part is to be there. So what exactly the meaning for the FCC, that is face center cubic? Now, in this case, as far as your first layer is going to be concerned, I will repeat. The one atom is surrounded by the six atoms that is there. It is the same A layer will be no change as far as your FCC is to be there. That is face center cubic is to be there. That is to be the similar as good as whatever you have seen in the HCP. The FCC's first layer is also having the same structure, but again the second layer, that is to be given with this fashion. Three atoms are to be there, which covers the whatever the values are remaining grooves are to be there, that is covered by the second layer B is to be there, which contains the three atoms are to be there. Now the difference for the your HCP and FCCs comes with the third layer. In the third layer, there are again the three atoms are to be there, and which are going to be covering whatever be the remaining values are to be there of the A layer is to be there. म्हणजे ए लेअरमध्ये जे काही ग्रूव्ज व्हॅल्यूज होत्या त्या कव्हर करण्यासाठी हा बी लेअर होता, पण त्यानंतरही काही व्हॅल्यूजच्या ग्रूव्ज उरलेल्या होत्या त्या कव्हर करताना हा थर्ड लेअर इज टू बी देअर कव्हरिंग दॅट. It is like differences are to be there. So what the nature for the layers for the atoms are to be there? A, B, C. Again the third layer will come with to be as a similar in this fashion with the seven atoms that will come with this, that will be again in this fashion. So next will be layer with the three atoms, and again with the six. So in this fashion the crystal structure will be having the structure A, B, C, A, B, C likewise there. So this is what the difference as far as the layers are going to be formed. So this is very basic difference in between the your HCP and the FCC. In the FCC, additional third C layer is having the variation, and what is exactly that variation we have seen. And such type of the ABC structure is going giving you the solid in that case. So such type of the layers are nothing but to be called FCC is to be there. So in this case, the third layer is only different. Now as far as the coordination number is again to be as an 12 is to be there, as your closed packed structure it is showing, that's why it is having the 12 atoms are surrounded by, each atom is surrounded by the 12 atoms. As far as the effective number, if I want to calculate, if you look at the all the atoms are exactly are on the corners, in that case the whatever be the your unit is going to be formed, in that case it is nothing but to be giving you 1, that is plus whatever be the 6 atoms are to be there, it is somehow divided in the half of the part, and that's why here it is, if you look at it, will the effective numbers value will come to be as an 1 plus 3, that is nothing but to be your 4 is to be there. So as far as the effective numbers is to be there in the FCC, it is giving you basically the effective number is to be 4, as the 6 of the atoms are to be there, in this fashion it works likewise. Now in this case also, the whatever be the relation between the your uh, uh, radius of the your whatever be the atomic radius and the interatomic distances are to be there. It is somehow given in this fashion. The length of the edge called as a in this case. So whatever the relation between the interatomic to distance of or the sorry length of the edge and the your radius of the atom, that is to be given in this case, and that is this 4r is equal to under root of 2a is to be their relation in between them. As the packing fraction is going to be calculated in this fashion, so it will come to be again to be as an here calculated values to be 0.74 is to be there. So again in the FCC it is also giving you the packing fraction in that case. So whatever be the examples under this FCC comes to be as an Cu, copper as well as silver, aluminums are the basically metals found in this your whatever be the FCC is to be there, as far as the face center cubic is to be there. So this is how the your FCC and the HCP is to be having the differences, and both are come under the closed packed structures are to be there. So it is very simple one, the but very having the compact atoms are to be related in contact with each other, and that's why it is having the packing fraction is greater 0.74, and the coordination number is nearly to be 12 is to be there. So once again, thank you very much, and be at home and be safe. So those who missed my previous lectures, those who can attend my wants to attend my previous sessions, they can go to my channel and subscribe, or if you want to see the my previous sessions, you can go to my channel and you can see anytime updated whatever be the, if you want the um, videos you would like to see. For that you have to subscribe, otherwise the sessions will be continued. Thank you.